For this lesson today, what we're going to get into is your gas burners. Now, in natural gas, propane, your gas grills, you've got to have something there that's going to deliver the gas to your appliance so that you can deliver heat. So what is a gas burner? Well, a gas burner is really nothing more than a device that's going to mix your air and gas from your manifold to burn a flame aimed into a furnace's heat exchanger. Gas combustion occurs at the gas burner. This is where the ignition actually occurs. Your gas burners are very, very simple in design. There is nothing complicated about them at all. Gas is carried to the burner assembly through a pipe with multiple openings, which is called the gas manifold. The gas manifold has small sockets which have spuds that are installed. The spuds are burner attachments with specifically sized orifices that direct the exact amount of heat and the exact amount of gas from your gas burner. The spuds are typically threaded into the gas manifold, and your gas mixed with a certain amount of primary air is fed through the orifice in the spud, which passes to the burner where combustion takes place and the burning gas mixes with your secondary air. So here we are. Here's our manifold, this black pipe right here. Here's our spuds, okay? And at the end of those spuds is a small little precisely drilled hole. There's our orifice, okay? These solid plates, these are your burners. Very simple construction. Nothing too complicated about how the burner actually operates. Here's another view of our spud assembly without the burners actually attached. Okay, here's our precisely drilled holes, which is going to be delivering the correct amount of gas to each one of our burners. And if you look kind of closely here, you will see a number stamped on the edge of it. That is the actual orifice size. And it looks like, to me, can't really read it too well, but it looks like maybe a 35. Now remember, those numbers are in metric. Okay? So what you're going to do is you're going to take a gas orifice sizing chart and compare that number to the amount of BTUs that should be delivered to each one of these burners. Now, when it comes to spud orifice size, be aware that the rate of gas flow through the orifice in a spud depends on the gas pressure and the specific gravity of the gas. Natural gas is light, so I don't need that much gas pressure. Only 3.5 inches of water column is what I need. Propane is a slightly heavier gas, so I'm going to need around 11 inches of water column to push that gas through my manifold and out my orifices. At equal pressure, less LP gas will flow through an orifice than natural gas because LP gas is a heavier gas. When converting a natural gas furnace to an LP gas furnace, remove and replace the spuds with a different orifice size for the different flow necessary for LP gas. Now, gas burners are used in your forced air furnaces. They're going to be used in unit heaters. They're going to be used in natural gas boilers. Your gas burner ensures that the proper mix of primary air and gas so it can be readily ignited and burned. We have two types of gas burners that we commonly run into in all of these types of appliances. They're going to be either an atmospheric burner or a power burner. Now, your atmospheric gas burner uses kind of like a siphoning action of gas flow through the orifice to induce airflow through the burner without the need of a inducer blower. These burners are usually constructed of steel. It may be of different lengths and sizes. Gas burners in older furnaces have primary air shutters that can be adjusted to regulate the amount of primary air that is added to the mixture. Where you would really find a lot of your adjustable air shutters were on the old standing pilot furnaces. Because of the old technology where we had a standing pilot, all we really needed was that flame to ignite the rest of the burners. So those types of burners kind of ran a little bit wild, I guess you would want to say, so to speak. So those burners used to have a little adjustable air shutter on the end of each of the individual burners. And to adjust the amount of air and to regulate the size of the flame to each one of those burners, we would either open or close those air shutters to kind of regulate the amount of BTUs to each one of those burners. However, newer furnaces really don't have adjustable air shutters on them anymore because they're a lot more induced draft. We're using the inducer motor to suck in our primary air and our gas into the heat exchanger at a given rate. So here is a view of one of our burners where we would actually maybe have an adjustable air shutter on them. What you have here is a crossover tube. These crossover tubes is what actually ignites the gas from burner to burner. You have your primary air that would get drawn into your burner, as well as your gas flow from your gas orifice. So as that siphoning action, as we were talking about in the previous slide, once my gas valve opens and delivers my gas to my burner, I kind of almost create a natural suction that draws my gas flow and some primary air to kind of mix inside my burner, which will then get drawn down to my burner and then out, where my actual flame will actually ignite. The body of an atmospheric burner has almost like an hourglass shape, as you could kind of see here. It kind of has like a bigger opening, but as it goes down, it kind of shrinks in size. Reason why we do that is because we want to draw that air and natural gas mixture all the way down to the very end of the burner so that we can have a consistent ignition and a consistent burn. They're narrower in the center and wider on the end. The narrower section of the burner produces a Venturi effect, which is the reduction of pressure that occurs when a fluid flows through a constricted section of pipe. So as the gas enters the atmospheric burner, it must speed up as it passes through the narrower area. When this happens, it creates a low pressure, which draws in air from the primary air shutter. The primary air mixes with that fuel gas as they pass through that narrow constricted center of the gas burner, and that Venturi effect produced by that narrower passage also causes the fuel and air to swirl and kind of mix together. You have different types and different styles of atmospheric burners. You have your ribbon, your slot, and your single port. Your ribbon burners feed the fuel gas and primary air mixture along the length of the burner, producing a solid flame on the top. Your slotted burners feeds a mix of fuel gas and primary air through a series of narrow slots. So here you have a slotted burner. So this is where your flame would actually be coming out after your fuel and air mixture occurs. and we'll light all of these. Your single port burners can be manufactured in a variety of patterns to meet specific design needs. The most efficient single port burner is called the Inshot burner. Okay, Inshot burners direct the mix of air and fuel gas through a large orifice to produce a large flame that is directed into the heat exchanger. Due to efficiency and the design of your heat exchangers, most new furnaces are going to have your Inshot burner. And that's what it looks like. So your gas orifice is going to sit right in here, which will now introduce some gas into your burner, which will also draw in some primary air to mix with that gas, and then the ignition will occur on the opposite end of the burner down here. Here is a better view of what we're talking about. So here you have your individual burners. So you got 1, 2, 3, 4, 5, 6 burners with your crossover tubes right here. Okay, notice how the crossover tubes are in alignment with each other all the way down. This is how the burner ignites from one end to the other. Here is your hot surface igniter. So basically how this is working is that the hot surface igniter is going to ignite this very first burner. Once that very first burner ignites, the gas will now flow through each individual burner all the way down to the very end, where it will now make contact with the flame sensor. That flame sensor will now send that microamp signal back to a circuit board, which will tell that furnace that all of my burners have now ignited. And if there's any sort of issue with my burner, here is a roll-off switch or my safety device that will now shut the burner off in the event of some sort of unsafe condition that may occur. Power burners is the type of burner that uses a blower to force both primary and secondary air into the burner tube. The burner tube has an angular deflector plate to spin the flame for more efficient burning. A spark igniter or a hot surface igniter is used to ignite the gas. And power burners are not common in a lot of your residential furnaces, but you will see them a lot in your commercial and industrial. The use of fuel oil requires a power burner or even natural gas. These burners are able to achieve higher burning efficiency due to their ability to better control the ratio of fuel to air. Your power burners can also be dual fuel as well, which means they have the ability to switch between either natural gas or oil. And here is a typical gas burner, and this here is a Carlin natural gas fired power burner. So here's your gas valve right here. Here's your gas line. Okay. Here is your actual ignition source, which here is an actual ignition transformer. Usually on these types of burners, you're going to have some sort of airflow pressure switch that is going to have to close to prove that the burner is actually on and inducing some sort of airflow down the burner before any sort of other ignition can occur. These usually have a adjustable primary air shutter that can be opened or closed to adjust the amount of air to our burner, and it will have some sort of ignition module on it as well.